Telescopes play a crucial role in astrophysics, enabling scientists to study the universe in various wavelengths and resolve fundamental questions about the cosmos. Here are some key connections between telescopes and astrophysics. Key connections of telescope and astrophysics. Observing the universe. Telescopes allow astrophysicists to observe the universe in different wavelengths, from radio waves to gamma rays, providing insights into various astrophysical phenomena. Understanding light. Telescopes help astrophysicists understand the properties of light, including its intensity, polarization, and spectral distribution, which is essential for studying celestial objects. Resolving spatial structures. Telescopes enable astrophysicists to resolve spatial structures, such as stars, galaxies, and galaxy clusters, providing insights into their formation, evolution, and interactions. Measuring distances and velocities. Telescopes allow astrophysicists to measure distances and velocities of celestial objects, which is crucial for understanding the expansion of the universe, galaxy evolution, and the formation of structure. Studying high-energy phenomena. Telescopes enable astrophysicists to study high-energy phenomena, such as supernovae, black holes, and neutron stars, providing insights into the most extreme environments in the universe. 1608. Zacharias Janssen, another Dutch spectacle maker, also claimed to have invented the first telescope in 1608. Janssen's design used a combination of lenses and mirrors to magnify objects. Key features of the first telescope. Refracting telescope. The first telescope used a refracting lens to bend light and magnify objects. Two-lens system. The telescope used a pair of lenses, an objective lens and an eyepiece lens, to magnify objects. Low magnification. The first telescope had a relatively low magnification power, around 3 to 4 times larger than the naked eye. Impact of the first telescope. The invention of the first telescope revolutionized astronomy and paved the way for major scientific discoveries. Galileo's observations of the night sky using his improved telescope led to several important discoveries, including 4 moons of Jupiter. Galileo discovered 4 moons orbiting Jupiter in 1610. Phases of Venus. Galileo observed the phases of Venus, providing evidence for the Copernican heliocentric model. Sunspots. Galileo observed sunspots, which provided evidence for the rotation of the sun. The first telescope marked the beginning of a new era in astronomy, enabling scientists to study the universe in greater detail than ever before. Over a period of time's new inventions, research on telescope began. Here's a brief timeline of major telescope inventions and milestones. 1609, Galileo Galilei improves the telescope. Galileo Galilei, an Italian astronomer, creates his own improved version of the refracting telescope, leading to several important astronomical discoveries. 1611, Johannes Kepler describes the reflecting telescope. Johannes Kepler, a German mathematician and astronomer, describes the concept of a reflecting telescope. 1668, Isaac Newton builds the first practical reflecting telescope. Isaac Newton, an English physicist and mathematician, builds the first practical reflecting telescope. 1781, William Herschel discovers Uranus. William Herschel, a British astronomer, discovers Uranus using a reflecting telescope. 1845, Lord Rosse builds the Leviathan telescope. Lord Rosse, an Irish astronomer, builds the Leviathan telescope, which remains the world's largest telescope for over 70 years. 1890s, spectrographic telescopes. Spectrographic telescopes are developed, allowing astronomers to study the light spectra of celestial objects. 1937, first radio telescope. Grote Reber builds the first radio telescope, a parabolic dish antenna. 1946, first electronic computer-controlled telescope. The first electronic computer-controlled telescope was developed at the University of Michigan. 1950s-60s, space-based telescopes. The first space-based telescopes are launched, including the Orbiting Astronomical Observatory, OAO, and the Uhuru X-ray satellite. 1990, Hubble Space Telescope launch. The Hubble Space Telescope was launched, revolutionizing astronomy with its high-resolution images and spectrographic capabilities. 2010s, next-generation telescopes. Next generation telescopes, such as the Atacama Large Millimeter, Submillimeter Array, ALMA, and the Square Kilometer Array, SKA, are developed, offering unprecedented sensitivity and resolution. 2020s. Future telescopes. Future telescopes, such as the Giant Magellan Telescope, GMT, and the James Webb Space Telescope, JWST, are being developed, promising even greater advances in astronomy. The Hubble Space Telescope, HST, is a space-based observatory that has revolutionized our understanding of the universe. Here are some key facts about the Hubble Space Telescope. Key features. Launch. It was launched in April 24, 1990, aboard the Space Shuttle Discovery. Orbit. Low Earth orbit, LEO, at an altitude of approximately 340 miles, 540 kilometers. Primary mirror, 9 feet 2.4 meters in diameter. 4. Instruments. 5 main instruments. Wide Field Camera 3, Cosmic Origin Spectrograph, Space Telescope Imaging Spectrograph, Advanced Camera for Surveys, and Near-Infrared Camera and Multi-Object Spectrometer. Hubble Telescope's discoveries and achievements. Age of the universe. Hubble helped determine the age of the universe to be approximately 13.8 billion years. Expansion of the universe. Hubble observed the expansion of the universe, providing evidence for the Big Bang theory. Dark energy. Hubble discovered dark energy, a mysterious force driving the acceleration of the universe's expansion. Exoplanets. Hubble has discovered thousands of exoplanets and studied their atmospheres and properties. Deep field observations. Hubble's deep field observations have captured stunning images of distant galaxies and stars. Hubble telescope's impact and legacy. Revolutionized astronomy. Hubble has transformed our understanding of the universe, enabling groundbreaking discoveries and advancing astronomical research. Inspiring future generations. Hubble has captivated the public imagination, inspiring new generations of scientists, engineers, and explorers. Paving the way for future missions. Hubble's success has laid the foundation for future space-based observatories, such as the James Webb Space Telescope. Hubble Telescope's fun facts. 1. Hubble's first image was of the star HD 96755. 2. Hubble orbits the Earth approximately 15 times per day. 3. Hubble transmits approximately 100 gigabytes of data per week to Earth. Since last 3 decades there have been significant advancements in telescope technology. Here are some notable developments. Space-based telescopes. The Hubble Space Telescope, launched in 1990, revolutionized astronomy with its high-resolution images and spectrographic capabilities. More recently, the James Webb Space Telescope, launched in 2021, has been making headlines with its stunning images and groundbreaking discoveries. Radio telescopes. The Atacama Large Millimeter, Submillimeter Array, ALMA, completed in 2013, is a radio telescope array that has enabled astronomers to study the universe in unprecedented detail. Optical telescopes. The development of advanced optics and instrumentation has led to the creation of powerful optical telescopes like the Keck Observatory and the Very Large Telescope, VLT. Computational astrophysics. Advances in computational power and algorithms have enabled astronomers to simulate complex astrophysical phenomena and analyze large datasets. Next-generation telescopes. The Giant Magellan Telescope, GMT, and the Square Kilometer Array, SKA, are 2 next-generation telescopes currently under development, promising even greater advances in astronomy. These advancements have significantly expanded our understanding of the universe, from the formation of galaxies to the detection of exoplanets. The latest developments in telescopes are truly exciting. One of the most significant advancements is the James Webb Space Telescope, JWST, launched in December 2021. The JWST is designed to conduct infrared astronomy, allowing it to study objects too old, distant, or faint for the Hubble Space Telescope. Future prospects of telescope. Next-generation telescopes. Next-generation telescopes, such as the Giant Magellan Telescope, the James Webb Space Telescope, and the Square Kilometer Array, will provide unprecedented capabilities for studying the universe. Advanced instrumentation, such as multi-object spectrographs and high-contrast imaging cameras, will enable astrophysicists to study the universe in greater detail than ever before. Computational astrophysics. Computational astrophysics, including simulations and machine learning algorithms, will play an increasingly important role in analyzing and interpreting astrophysical data.